Assalamualaikum and good day, class. So for this week, we will continue our lesson on chapter 3, water and its properties. So last week, we already learned about the structure of water and some parts of the properties of water. And today, we will continue to our second subtopic, which is properties of water, in which it will include high heat of vaporization, water expands as it freezes, and also water as a versatile solvent. In addition, we also learned about aqueous solutions, in which you will learn about the terms of solvent, solute solutions, and also acid, bases, pH scale, buffer, and buffering mechanisms. So at the end of this chapter, you should be able to determine the structure and also the properties of water, and also to describe the aqueous solutions and buffering mechanism. So let's recap back our last week lecture. So last week we already learned about the cohesive and the adhesive behavior of the water that are very important in the capillary reactions and also cause the surface tension to occur. And we also learned about the high specific heat capacity. And today we will continue the other three properties of water, which are high heat of vaporization, water expand as it freezes, and also water as a versatile solvent. So the first properties of water, high heat of vaporization. Vaporization, which is also known as evaporation, is actually referred to the transformations of substance from liquid to gas, meaning to say that how the additional amount of heat that water must absorb in order to change the water from a liquid state into the gas state, and this is what we call as the heat of vaporization. It's the quantity of the heat of a liquid that must absorb for 1 gram of it to be converted from liquid to gas. And to evaporate 1 gram of water at room temperature, which is about 25 degrees Celsius, about 580 calories of heat is needed. So as a liquid evaporates, okay, normally the remaining surface where the liquid place cools down, and that process is actually called as evaporative cooling. Thus, when the water evaporates, the water will change the liquid to gas, and it carries off much heat from that area. Okay, so the high amount of heat is used to break the hydrogen bond first, between the water molecules before it moves faster and transform into gaseous states. And evaporative cooling help actually stabilize the temperature in organism and also bodies of water. And there are two importance of the properties of high heat vaporizations of water. The first one is sweating, because as you sweat, the heat energy is actually transferred from your body to the water over here, and as the water turns into the gas by the process of evaporations, the heat energy is removed from your body that carries by the water, and you will feel very cold after that, and it helps to prevent the overheating from happens. And the evaporations of water from leaf of plants also helps keeps the plant tissues, particularly in the leaf of the plant, from becoming too warm, under the sunlight. Next is water expands is freeze. So molecules of water, they are far apart from each other when the temperature increase, and therefore they will takes up more. Okay. However, normal molecules like that. However, why do ice is less dense than water, since ice is in solid states of matter, and also water is in liquid states of matter. This is because, as you can see in the figure here, when the water is freeze, they will freeze in a hexagonal pattern. Okay, in the hexagonal pattern, compared to water in the form of liquid, and they will create more space between them. Therefore, this space actually makes them further apart from each other than they were as in the liquid water. Okay, making them less denser compared to the liquid water. So the importance of these properties is that it will help the ice cube float on the surface of the drinks. Okay, normally the expansions of the water on freezing result in ice having a lower density than a liquid water. Therefore, when the ice float, it doesn't sink into the bottom, which is why ice float on top of our drinks, such as your Milo ice, teh ice, okay, tea ice, and Coca-Cola, rather than sinking, okay, like a stone or like metal to the bottom of your drink. And also an iceberg that float on the surface of the oceans. So you imagine if the ice sank, all the bodies of the water such as pond, lake and ocean would eventually freeze solid in the winter, and it will kill all the organism or the life that live inside the water and making it impossible to live on the earth. So thus the ice float, okay, such an iceberg, is actually insulating the water below the ice that floating above the sea and prevent it from freezing. And it will also allow the aquatic organisms that live in the water to survive during the cold weather. So this is why the ice float, because the ice is less dense due to the hexagonal pattern that made by the molecules of the water, by making them further apart from each other. And therefore ice is approximately about 9% less than compared to the liquid water. So the density of the ice is actually about 0.9 gram per mil. Meanwhile, the water is about 1 gram per mil. And that's why this low density of ice making them float and floats on the water. And also the lake and the pond freeze from top to the bottom, so it will insulate the pond from freezing solids, okay, and it will protect also the organism in ponds and also lakes. Next is water is a versatile solvent. Because why we call water as a versatile solvent? Because most of the substances can be dissolved in water. This is because of the polarity of the water molecules. Okay, and there are three terms that you have to remember. The first one is solutes. So what is solutes? Such as the salt here. Solute is actually a substance that later will be dissolved into the solvent. Meanwhile, what is solvent? Solvent is the substance that can dissolve the solute, and the mixture between the solute and also the solvent, we call it as a solution. So the importance of water as a versatile solvent is that first, for the transportation of materials or any essential nutrients for our body to the cells, in which water is a carrier. It will help to transport the essential nutrient to our cells, such as the minerals, vitamins, and also glucose. Next is for the chemical and metabolic reactions in the living organism, in which water helps actually to remove the waste products such as a toxin from our cell inside our body through the urination process and also through the faces itself. So for the next topic is that we will look further into water, okay, as an aqueous solution. So aqueous solution is referred to any solutions, okay, in which the solvent is water. Okay, occasionally the hydrogen bond, okay, normally the water, okay, is made up from two hydrogen bonds, okay, it made up of two hydrogen atoms that share its electron with one oxygen atoms, okay. And normally these two water molecule they can shift from one molecule to another. So the water molecules, okay, that lost its protons, okay, that lost one hydrogen atom to another water molecule. This one is now called as the hydroxide ion. Okay, they lost one proton. Okay, meanwhile, the water molecule that received that extra proton, okay, as you can see over here, is now known as the hydronium ion. So in simpler way to view this process in water molecule is that water keep on dissociating into hydrogen ion and also hydroxide ion, okay, from the H2O. So in pure water, actually only one water molecule in every 554 billion is associated, in which at equilibrium the concentrations of hydrogen ions or the hydroxide ion is about 10 to the power of negative 7, okay, molar at room temperature at 25 degrees Celsius. So because of the hydrogen and hydroxide ion are very reactive, so the changes in their concentration can affect the proteins and other molecules of the cell. So actually, by adding certain solutes, okay, solute is the substance that can dissolve in water, such as called as the acid or bases. It actually will disrupt the equilibrium of the water, and later it will modify the concentrations of hydrogen ion and also the hydroxide ions. And the scale that used to describe the acidity and the alkalinity of the solution is known as a pH scale. So let's look further into what does it mean by acid actually. So acid is a substance that can increase hydrogen ion concentration, okay, rather than increasing the hydroxide ion. So normally, such as the when HCl or hydrochloric acid is added into the water, hydrochloric acid is one type of the acid. The hydrogen ion will dissociate from the chloride ion, okay, and they will donate this hydrogen ion to the water molecule and thus increase the number of hydroxide ion in that hydrogen ion in that solution, making it more acidic. Meanwhile, base is vice versa. It is a substance that reduces the hydrogen ion concentration in the solution. And some bases that reduce it directly by accepting the hydrogen ion, such as the ammonia and H3. Okay, it acts as a base when the nitrogen unshare electron pair that will attract this hydrogen ion and forming from the solution. Thus, it will creating or forming what we call as the aminium in. Okay, so in other bases, they will reduce the hydrogen ion directly, okay, indirectly by dissociating, okay, the hydroxide ion. Thus, combine this hydroxide ion later will combine with the hydrogen ion and thus forming a water. So in alkali solution or basic solution, the solution normally will have more hydroxide ion compared to hydrogen ion. Okay, so this is the examples of acids. Strong acid is about HCl. As you can see here, the water will receive the hydrogen ion from the acid. Meanwhile, for this one, for the basic solution, they will donate, okay, the hydrogen ion to the base. So as I mentioned earlier, pH scale is the scale that used to determine the acidity or the alkalinity of the solution. pH itself is actually referred to potential hydrogen. It's measure the free hydrogen ion concentration by, we read it as negative log 10, okay, hydrogen ion, and in which it water does not ionize readily. So normally pure water will have 10 to the power of negative 7 molar free hydrogen. Thus it is called as a pH 7. Okay, so the sum of the exponent of the free hydrogen ion and also hydroxide ion is always 14. Okay, so that's why we have pH 1 until pH 14. So given that hydroxide ion, you can easily calculate the hydrogen ion or vice versa. And normal or neutral water is actually pH 7. However, when the water itself has excess number of hydrogen ions, it will become acid, which is the acid, the pH is less than 7. Meanwhile, when the water have reduced its hydrogen ion or the number of the proton, it will become an acid, a basic solution, in which the basic solution, the pH is normally more than pH 7. And hydrogen ion do not exist in water, okay, such as instead they will combine with the water to make H3 O plus, or what we call as the hydronium ion. And in neutral solution, the number of the hydrogen ion and also the hydroxide ion is similar, which is about 10 to the power of negative molar. And by adding acid to the solution, it will shift the balance of the hydrogen ion and also hydroxide ion. It will leads to the increasing of the hydrogen ion, and it will leads to the declining of the hydroxide ion. Meanwhile, vice versa, with the base does the opposite. The base will increase the hydroxide ion in that solution and decreasing the hydrogen ion in that solution. So when the pH decline, actually the proton number is increased. So while the pH scale is based on the hydrogen ion concentrations, the value of hydroxide ion is actually can be easily calculated, okay, from the product relationship. And as I mentioned earlier, pH neutral is about 7. Acidic solution, the pH is more and less than 7. For basic solution, pH values is less and more than 7. Acidic less than 7. And most of the biological fluid is actually have the pH range about 6 to 8. However, the stomach, human stomach, is very very acidic, in which the pH can reach to pH 2. And each pH unit represent a tenfold difference in hydrogen ion and also hydroxide ion, its concentration. So now we're gonna look into buffer. So buffer is referred is actually referred to the solution that can accept the hydrogen ion from the solution if the hydrogen ion in the solution is excess, and they can donate the hydrogen ion to the solution when the hydrogen ion in that solution is depleted. So the function of this buffer is actually to maintain the cellular pH values at a constant level. So typically it consists of a weak acid or its corresponding base. And one important buffer in our body, in human blood specifically, is called as a carbonic acid. Okay, as you can see in the figure here, the equilibrium is shift left or right by adding or remove the hydrogen ion from the solution. So class, after this, please try to answer this question. Number 1, identify which of the following values would represent the pH of a strong base. A, pH 1, B, pH 8, C, pH 7, D, pH 13. And for question number 2, ocean water has a pH value near N. It would be classified as blank. A is slightly acidic, B strong base, C neutral substance, and D is slightly basic or known as alkaline. And for last question, number 3, identify the characteristics of water molecule that make it as a great solvent. A is water demonstrate polarity, So they're having a partial charge at the end of hydrogen and also oxygen atoms of the water molecule. B, it is due to its molecular formula. C, it has linear molecular shape. And D is due to its non-polar molecular structure. So I think that's all for today, class. Thank you.